This conference will now be recorded.
At the agenda. So first there will be the welcome and the introduction, which we are right now doing. We'll have a very short look at the project. It will be done by me. I'm working for Attico ITS Europe and as a manager for interoperability and standardization, and I'm not the coordinator from our side for 5G login off, but I'm standing in for him as he's busy with something else. Then we have Professor Panagiotis Drakadas for affordable 5G and Professor David Gomez Barquero for FUDGE-5G. And after that, we get a bit more detailed descriptions from each project, especially from the living labs of 5G login off, from affordable 5G and FUDGE-5G. And then we have a panel discussion and question and answers. So either you have a few good questions, the audience, and we answer those, or I prepared a few questions that we can discuss as well. So let's close this here, because now we immediately move to this. So as I said, that will be a very short intro per project. Let's start with the 5G login off project. And 5G login off has the vision to optimize rate and traffic operations at ports and logistics hubs by using new innovative concepts, applications, and devices supported by 5G technologies. And then the other things, Internet of Things, data analytics, next generation traffic management, and 5G logistics corridor. We have 15 partners in that project from 8 countries, 3 pilot sites, Hamburg, Athens, Koper, who will give you a detailed description of their pilot sites later. The duration is from September 2020 to August 23. Or did we go for amendment? Don't really remember. We have a budget of close to 8 million euro, and their website is 5gloginoff.eu. Well, very shortly, the project concept is about to deploy, evaluate, and showcase the added value of 5G technology, especially for logistics and ports in the 3 living labs. And with that involve the major telecom industry stakeholders that have to provide the 5G network and realize port-driven technological and societal innovations. And an important point, it's a stakeholder-driven approach. So taking into account the challenges that apply to ports and port cities and due to the evolving environment. As I said, details later. And here you get the partners. So you see we have telecoms, T-Systems, Telecom Slovenia, we have the ports, Koper, and other companies, so Piraeus Port and so on. So that's all for 5G login off. As said, just a short intro. So I hand over to Professor Drakadas for affordable 5G. Please go ahead.
Thank you so much. So would you share the screen, the presentation, or shall
I? You can go ahead. I can see your presentation.
Excellent. Yeah. Okay. So my name is Panagiotis Drakadas. I'm the technical work of affordable 5G. Just to give a very short introduction about affordable 5G. This project was funded under the ICT 42, and the main objective the center of gravity, let me say, is how to apply innovative technologies to support non-public networks, as called by the 3GPP, or private networks, as everybody knows. In the main architecture, we have identified 3 different layers. Starting from bottom, there is the infrastructure layer, where you can see all the core and the edge and the regional NFV infrastructures, the transport network segments in the middle, and of course some cell-site platforms. Going up 1 layer on the yellow marked components, you can see the basic functions and components that comprise the core and the radio access network part, with some innovations there that I would briefly describe in the next figure, in the next slide. And on top of that, on the higher layer, on the 3rd layer, we can see everything related to the management and the orchestration of the whole infrastructure. Like the orchestration, different slicing options managed through a slice manager, telemetry and data analytics, and machine learning based radio access network optimization. So this is just a brief overview of the architecture. Going to the next slide, where we can see we have highlighted, we have spotted the main innovations that we have focused and that we are already in a good position, also disseminating the results already. The first one is the connectivity between disaggregated O-RAN components. This is something that I would like to highlight, that we are one of a few projects that we are truly working on how to integrate these Lego blocks that they comprise the Open RAN 5G network on the radio access part. We have worked hard on identifying different machine learning algorithms, taking advantage of the XApps as defined in the O-RAN specs. I've done a lot of work on the management of the slice life cycle and management of different slices to support different private network requirements. We have one use case, and we have identified some potential interest from the consortium towards TSN networks, especially the implementation of the translators. TSN stands for time-sensitive networking, that it is very hot also in the ETSI 3GPP specs, and the main building block around Industry 4.0 applications. We have also collaborated with OSM partners, and we had attributed the OSM work. And we, of course, we are looking on the network telemetry, and we are following all the specifications on release 16 in this network telemetry work. In particular, we have implemented the first open source NWDAF specifications according to the release 16 specifications. And the last slide, just a brief description of the 3 use cases where all these innovative technologies that we have implemented have been demonstrated. The first one is a mission critical service. The second one on the top right is based on the lamp post that UBWare brought to the project. And well, it is a very demanding use case with respect to latency and bandwidth characteristics, especially, you know, UPFs moved at the edge and things like that. quite innovative, but also the list of requirements is huge enough. And on the bottom, you can see the third use case, that it is related to the time-sensitive networking. That we are working on that in with the University of Malaga. And the last slide is not just about the next one. Sorry for that. Yeah, we have included it not only to show you the partners, but to highlight the fact that at least for the radio access network, and as we are following the ORAN specifications, I want to highlight that we have one partner dedicated for each one of the components comprising this ORAN architecture. So we have RANEL for the RU, EURECOM for the BU, Celeran for the CU and the near real-time RIC, I2CAT for the non-real-time RIC. That means that we have one partner for each one of these building blocks, the Lego blocks, as we call the ORAN architecture, and of course Athonet for the core. And in the perimeter, there are many SMEs and universities that we are struggling to support the industries to bring the use cases into reality. Thank you very much.
Okay, good. Thank you very much for that quick overview of the affordable 5G project. So let's move to FUDGE-5G. So I would like to ask Professor David Gomez-Barquero.
Thank you, Peter. FUDGE-5G, it's actually it's a project of the same call than affordable 5G. And instead of focusing on the RAN, or we actually, it's one of the few projects in 5G PPP that focuses on the 5G core. In addition to that, we strongly focus on the SBA, the service-based architecture. And let's say our scenarios are all of them are on private 5G networks, or MPNs, as you can call it. So please go ahead to the next one. There you have the main technology innovations of the project. I would like to stress the service-based architecture that we had a demo last week at UCMC. Maybe some of you had the opportunity to see it, and it's actually one of the topics for the more detailed presentation that will take place later. So I will not get into that. A very interesting research topic of our project that always brings attention is the a design of the 5G core network functions as microservices. So as you know, with the move to the cloud, the monolithic software can be put into a container, but that doesn't make it cloud native. So the project is working on designing and developing some network functions of the 5G core as microservices. And as we have actually 3 5GC vendors. We have some use cases that are some experiments with multi-vendor setups. And then, in addition to that, we have some work like 5G LAN, TSM, integration of public-private networks, and so on. So let's go to the next slide, please. And that's a difficult slide, but I guess basically it will be explained later. So what we have been working in FUDGE is what we call our FUDGE 5G platform that is based on the SBA, actually it's SBA component, let's say, in order to not repeat platform again, from Interdigital. In addition to that, we have 3 5GC vendors, Athonet, that is also in affordable 5G. We have Kumucore and Fraunhofer Focus. We have also a number of applications, vertical applications. And well, I think I let the telemetry and the lifecycle management and so on, the routing will be explained in more detail later. So we can move to the next slide. And it's very important in, or the previous one, there was one on the, yeah, that one.
Okay. I was a bit too fast, sorry.
Yes, you went 2 slides. No problem. So we have 5 use cases, and well, we have Telenor. Our testbed is basically in Norway, and it's very important to say that we have like the vertical end users, what we call our vertical stakeholders. So, for example, we have a media use case, and the stakeholder is NRK. The public Norwegian broadcaster, the PPDR, we have the Norwegian Defense Materiel Agency, the industry use case, we have ABB, and what we call the 5G virtual office, which is being deployed at Oslo University Hospital. So that's very important, and it's to achieve a high TRL level. And then in addition, we have a 5th use case that is about the interconnection of private networks. So we have actually currently interconnected a private network in Berlin and at Fraunhofer Focus, and another one in Valencia at UPV. And we plan to connect a 3rd one in Norway. And I have to say that this possibility is not actually possible in the standard. So 3GPP has not yet defined how to interconnect the private networks. Of course, there are different ways of doing it, but we have actually proposed one way and implemented it and show it. So now we can move to the just final slide with the partners. We basically have mentioned already most of the partners. Just to say, we have, in addition to our vertical stakeholders, we have a very strong and large advisory board, because we have also technology experts on the different technical topics in the project. We have a support of different cloud edge solution providers, and even we are making some specific collaborations for the demonstration of some use cases. So that's it. Thanks for your attention.
Okay, thank you very much, David. So from that was the short overview. Mm-hmm. And so this is finished now. So I close this. So basically, now I guess probably I have to open the agenda again to find out who is first for 5G login off. And I think it's the Athens Living Lab. So
yes,
now
hello
you get
everyone.
an overview from the Living Lab. So I guess we have to make you presenter, Pavlos. Mm-hmm. Just wait a second. There you are. Make presenter. So you should be the presenter now.
Yes. Hello everyone.
So we can see
slides. You can see the slides in presentation mode. Okay. So hello everyone. This is Pavlos Basaras. I am with the Institute of Communication and Computer Systems. In short, this is ICS. ICS basically leads the Greek pilot for the 5G login off project that takes place in Athens Living Lab. And in the following slides, we will basically see how we exploit commercial 5G technology and our use cases for efficient freight and traffic operations at our port in Athens Living Lab. So basically, this is the view of our port, operated by Piraeus Container Terminal, PCT in short. This is how it looks like in the bottom figure. Basically, we have 3 functional piers. A few words for our port. We are part of the Trans-European Transport Network. This is basically the network graph that you see at the top figure. We offer port consolidation and distribution services. We are ISPS certified, which basically means that we follow relevant security and management regulations with respect to ships, cargo, and crew. We are well connected to the Balkans and Central Europe through road and rail transportation networks. We operate as a free zone area type 1 with all the VAT-free benefits and improved cash flow management. We offer transportation services for containers, but also for roll-on, roll-off cargo, which basically means wheeled cargo, such as vehicles and trucks. And with respect to some statistics, basically, Piraeus Container Terminal is ranked first in the Mediterranean and fifth in Europe in terms of container throughput. So basically, this is an overview of the use cases. We basically classify them together in two main categories, the 5G track telematics class, and the other one, which is based on 5G and AI-enabled services with NFV MANO support. We have three main partners, PCT, which is our port operator in Athens Living Lab, ICCS, which mainly brings the NFV MANO platform, the 5G IoT system, and the AI-enabled services that we will see in the following, and Vodafone, which is our telco operator, provides the 5G network, as well as leads a use case which has to do with 5G tracks, external tracks, which are inbound at the Port of Piraeus. Currently, we have a private 5G non-standalone network operational within the port premises, which communicates with several end devices, such as 5G cranes, 5G trucks, 5G IoT, 5G UEs. In the branch of 5G track telematics use cases, we deal with real-time monitoring of the logistics supply chain. Basically, here we are talking about use cases with respect to predictive maintenance and real-time coordination of 5G tracks, yard tracks within the port terminal, as well as coordination with external tracks inbound at the Port of Piraeus as well. For the branch of NFV MANO-enabled services, basically we deal with two types of use cases. The first goes with safety and security applications, and the later is more tailored, let's say, to the logistics domain. For the safety part, we exploit the broadband connection of 5G and low latency transmissions to deliver a 5G and AI-enabled yard track collision avoidance system between trucks and personnel. Another safety application includes the AI-enabled detection of human personnel in several risk areas within the port premises. Now, this defines areas, for example, with heavy truck traffic or heavy crane operations. And finally, the logistics use case deals with 5G cranes and the detection of container seals at the loading and unloading process of vessels at the Port of Piraeus in PCT. This is our private 5G non-standalone network. It's currently deployed, the base station is deployed in PR3. The model is based on the remote radio unit you see here, and what it looks like in real life is what you see at the right most part of this figure. We operate with a non-standalone core of release 15 at band 78 at 3.7 gigahertz, and currently we have a channel bandwidth allocated at 100 megahertz, with some experiments illustrating throughput measurements of about 1.5 gigs in downlink and above 100 megabps in the uplink direction. So this is basically our NFV MANO platform and 5G IoT system. It's a cross use case, let's say, platform. First, we go with open source MANO of release 11. So basically, this holds the repository of the KNF descriptors that bring together all the AI ML components that are going to be distributed to the 5G nodes, whether it's a truck or crane or IoT node within the port premises. It goes with a Kubernetes cluster, which finally distributes all the relevant manifest files to the edge nodes, and over 5G, where again, use case 5 deals with 5G cranes and the detection of container seals. Use case 4 basically deals with safety and security in risk areas within PCT and AI-enabled video analytics services. And finally, use case 3 is our 5G-enabled rapid alert delivery system for collision avoidance services. So if we would like to go in a bit more details, this is our AI-enabled rapid alert delivery system. A high-level architecture is shown in the top part of the figure. So basically, our truck is equipped with a 5G modem for cellular communication within the port premises and a 4K camera to establish 4K uplink video transmissions through our edge computing data center. Now, the edge computing center is basically where our Mano and Kubernetes cluster reside, and this is where our orchestration of the relevant CNFs deliver the collision avoidance systems for the use case. In let's say, high-level overview, the alert system looks like what you see in the bottom right part of the figure. In case that we infer through our CNF services that there is no person in proximity to, let's say, the bounded box that you see here at the figure, then at the cabin, at the tablet installed at the cabin of the truck, you see a blank screen. Whereas if let's say a person is detected within the bounding box, then 4K inferenced video streams are transmitted directly to the terminal, also along with, let's say, rapid alert systems. This is sounds delivered to the truck driver in order to avoid, let's say, collision events. So this exploits basically EMBB in both uplink and downlink transmissions, as well as low latency for a rapid alert delivery and collision avoidance service. Use case 4 goes with 5G and AI-enabled surveillance for video analytics. So basically here we're monitoring through 4K live video streaming several areas. Area 1 is close to the rail system, and Area 2 is basically close to the operation of the quayside cranes, where no human personnel should be present. In a similar fashion, 4K uplink video streams are transmitted to our edge computing center. There, the Mano cluster distributes the CNFs responsible for detection of human presence within these areas. And the inferenced video streams and alerts are delivered basically to either a central monitoring system or to a handset for a patrol ship that is close and nearby to the area in order to intervene and avoid any potential issues. So the top left figure basically shows how the in-lab development looks like. And then at the bottom left part of the screen, you see the 4K camera inspecting Area 1, basically, for this particular slide. Use case 5 deals with the 5G cranes. Now, a quayside crane is what you see basically in the bottom left part of the figure. We have lane 1 and lane 2, which is the lanes to which trucks arrive to be loaded or unloaded with containers. The camera area basically depicts the 4K camera installation on installation points on the quayside crane. They are collected via gigabit Ethernet link to the crane cockpit. And the crane cockpit basically looks like the middle figure at the bottom. So basically there we have an edge computing device. This is based on NVIDIA's AGX Xavier model, and the cellular interface to establish the communication within the ports. Now, for this case, the CNF is distributed to this particular device over 5G, delivering the AI-enabled service for detecting the container sales at the unloading process. Now, this is basically a twofold approach. At the first step, we extract from the 4K frames the part of the frame that illustrates the container door. And from the abstracted phase, we try to detect the presence or absence of container seals within the premises. To monitor the entire service at PCT's main management platform, basically those 4K uplink inferenced video streams are transmitted to have, let's say, the visual inspection of all the crane operations during their when they're handling the operations from the ships. All the services that we have seen so far basically go with NFV Mano support from day 0 to day 2 operations, and the service orchestration goes through CNFs and lifecycle management based on Mano services. And all components so far can be deployed both as far-edge services, meaning on device, as in this particular case, or at our, let's say, edge computing center over the 5G medium. The next and last set of use cases goes with the 5G yard trucks. So basically, other than the 4K video streams that are transmitted to and from the yard trucks, we also have equipped on the trucks a telematics device. The device is basically connected to other on-track sensors, such as CAN bus, GNSS, container presence sensors, and so forth. And all this telemetry data from the fleet of connected trucks are transmitted to the central platform, which basically gives you the overview that you see in the image. Now, this is, let's say, the live operations at PCT premises. where you basically see the position of the tracks, their current carried freight, their moving direction, their moving speed, as well as the live open jobs currently available at the container. The job here basically means the horizontal movement of container between, let's say, a vessel to a storage area to the road or a road transportation system. This telematics data basically fuel use case 3 for the real-time job allocation and traffic coordination services within the Port of Piraeus, whereas Canvas data drive use case 7, which is basically a predictive maintenance services in order to reap the benefits of predictive maintenance versus corrective maintenance and drive make a data-driven schedule of purchases than dealing with a problem when it occurs at the breakdown event of, for example, a 5G truck within the port terminal. The last use case is use case 2. This is mainly driven by Vodafone. It has to do with 5G trucks external to the Port of Piraeus that are inbound towards the port. Its application is twofold. Basically, it gives the port operator a view on estimated arrival times of external trucks at the Port of Piraeus in order to coordinate and expedite the loading and unloading procedures of those trucks within the port terminal. And once inside the port, live localization and video data between yard and external trucks are exchanged in order to expedite, let's say, the handover operations between the trucks. And this is basically the use case overview for our 5G IoT device plane. We go with 5G and AI-enabled services with NFV Mano support, and the 5G track plane, which all are interconnected to our Mano cluster, which also entails the streaming management module, the inference management module, telemetry management module, and all the relevant UIs and dashboards to let's say, to view the entire procedure and monitor the lifecycle management of all operations. I think this is the last slide for me. Thank you very much.
Good. Thank you very much, Pavlos, for this presentation of the Athens pilot site of 5G login-off. So I will immediately switch to Ralf, who is going to present the pilot site in Hamburg. So I'm Ralf. I'm making you, well, I try to make you presenter. Maybe I have to. Well, somehow doesn't seem to work.
Then maybe you can take.
So
now something's happening.
Now it's happening. Sorry. So, oops.
Oh, there's something wrong.
We see your slide very often.
Too often, yeah. I don't know why this is going to happen. Maybe I should change the screen.
Now we see something that says container Umschlag.
Yes, and can you see now my first PowerPoint?
Now we can see something, but we see we don't see the presentation view.
You don't see the presentation view, okay. Then we have to try it again.
Yeah, it's usually if you have more than one screen, it doesn't really work very well.
Yeah, that's probably the challenge. Can you see it now?
Well, it's...
Or again, not working.
Ralph, I think if you press, I don't understand German, the second or the left at the top part of the screen, if you go in presentation mode. There are three buttons. Yes, if you go to presentation mode, at the top left part of the screen that you're going to see, there will be three buttons. One of them basically switches the screen that you want to see.
This one?
Understand. Go to, now it's frozen, I'm not sure. Are you in presentation mode?
Not yet. No.
If you go
to I'm in presentation mode.
Yes, there are the top.
Oh, yeah, okay, yeah.
One of them switches the screen to the one. The top part of your screen. The top three. Each one of them. I'm not sure which one.
The second one. Anzeigeneinstellungen.
Okay. And then.
One of these will be the screen, the right screen.
The first one. Yeah.
Now we have
Okay.
it. Okay.
Now it works.
Thank
Go
you for
ahead.
your help. Okay, go ahead. So let's go to Hamburg now. The first thing I wanted to highlight is that in principle for the use cases in ports, you have two areas of interest for 5G. One is inside the port, the other one is outside the port. And Hamburg being number 3 in Europe, number 1 in Germany with roughly 9 million containers per year throughput, has a huge challenge also given the fact that the river Elbe is not directly located to the Northern Sea with the hinterland connection. And in order to improve the overall connectivity to the railway system, which is besides Chicago one of the most important worldwide, for Germany's economy very important. We decided together with the city of Hamburg, which has an ITS strategy until 2030, to go to the hinterland and to study use cases which are located in the hinterland and not directly in the port. So it's fully complementary to Athens and Koper. And with regards to what we are studying in the hinterland, we have use cases which deal with floating car or floating vehicle emission data, and we have the aspect of green light, optimum speed advice, and automated platooning, and as well a direct link to the traffic management center with our partners in the Living Lab. In the 5G context, of course, I want to highlight where we are actually needing 5G technology, especially for platooning and collision warning. We have very high requirements to the low latency functions of the network. And also for real-time tracking, we have enhanced mobile broadband and huge data, and we have mobile edge and 5G enabled precise positioning, which are directly linked to the 5G features. Here's again listed how the roadmap is and how we see the world of these use cases in the context of the network developments in the near future. And we really have a look on ports and hubs because they also have the net zero strategy and high requirements in the near future for improvement. So the thing now bringing you to Hamburg, you see the two areas where we already started to pilot these use cases. One is located on the road network to the terminals. Here's a bridge where vehicle to X technology was implemented, and the core application and use case is actually happening inside the city. So if you can see my mouse here, basically the terminals around, they include ferry terminals, cruise terminals, and inside the city is the vibrant day and night life of Hamburg. So there is a lot of traffic, vulnerable road users, logistics to be organized. The test track has 68 traffic lights connected to the mobile network and also to the communication from vehicle to traffic light and back to the vehicles. And that's installed exactly in this area you see here in red. Technology-wise, the 5G network is the data exchange center for traffic lights, for service centers, and also from the vehicle sides. And the vehicle itself uses 3 different technologies from telematics to smartphone, and the data is transferred also with a continental IoT device via 5G to the different service layers. In Hamburg, for the exciting ITS Congress, we had the pleasure to show first time how the system works, and that it works. You see here to the right the different green light, yellow, red phases per lane. We also had already a link to the traffic management controller and roadside units. It's a hybrid communication channel, and the ITS server and the mobile edge was used from the telecom public network. From the overall architecture of the use cases, you see here that some of them can be implemented with the traditional 4G LTE network, but especially when it comes to the automated platooning, collision warning, and to other services linked to precise positioning. To give you an example, sometimes the GPS has jitter and changes of up to 50 meters, what we found. This, of course, is not acceptable if you want to have a real operation in the service level agreement with the city. So these are the areas where we really need 5G. And if you imagine that we have 70 taxis already connected, in short time, they already sent 70,000 trips to our database. We also see definitely a big data system which is needed in the context of 5G for real environmentally friendly traffic management. The platooning tests are very promising. You see here results from a platoon of 7 vehicles above to the right. And these are the stop times, very important when it comes to the effect of traffic light and to the energy transmission and fuel consumption. And instead of having a smooth speed profile, what actually happens is that a manually driven platoon by nature has a lot of following vehicles with higher acceleration and more energy consumption, and this we measured in the way that we also can report the impact of such systems to reducing CO2 emissions and emissions in general in the city. When it comes to the interaction vehicle to vehicle, we made the first calculation and will continue this with some network tests, runtime and latency tests. What are the requirements to keep a platoon collision free and also to send the collision alert to the vulnerable road users? And this gives the very high requirements to latency in the network. And here you see the 3 devices per vehicle, also the Continental and the Tech4U platform, and in the context of the network. With regards to carbon footprint, we developed together with our friends from Ertico, Peter, you know him now here in the call, an ISO standard, which since June 1st of June is invalid and no longer under examination. So the first implementation in projects here can help the Hamburg authorities because the investment into such an infrastructure is significant, several millions, but if you imagine the effect which was found in other similar projects of up to 50%, which you have by coordinating isolated traffic light controlled intersections, it will be very important also to measure the exact impact and CO2 reduction. And now I'm looking to the watch, that's it. Peter, I think timekeeping will be difficult.
Well, thank you, Ralph. You kept your 10 minutes, so but we're still running a bit late. So
okay, that's fine. But we will have discussion enough and for the other projects.
yeah.
Thanks, Peter.
So then I will hand over to Janez Sterle from the Living Lab in Copper. So let's try to get that done.
Yeah, good afternoon from Slovenia.
So you are presenter now, it seems.
Perfect. Just a second.
Okay.
I guess you can see my screen.
Yes, and it's perfect. Go ahead. Janez.
That's very good. So thank you very much. So my name is Janez Sterle. I'm coming from Internet Institute, which is an SME based in Ljubljana. In the 5G Logino project, I'm also leading development and deployment activities of Copper Living Lab. So my goal today is to share with you insights, knowledge, operational experience from the 5G Logino related development, of course, in the Copper Living Lab. So Copper Living Lab is hosted by Port of Copper, which is managed by Luka Copper Company. So it will be a lot of copper names. Port of Copper is a medium-sized, multi-purpose European port with several specialized terminals, as you can see it here. It's located in the Koper municipality in Slovenia, and it is the only Slovenian multi-purpose port connecting Central Europe with access to Adriatic and, of course, to the Mediterranean. In the case of Copper Living Lab, we target development, deployment, and on-the-field verification of novel 5G capabilities, such as 5G network operating in 5G non-standalone and standalone mode, and of course, additional complementary technologies such as MANO-based network and services orchestration, in our case assured by OSM, where we are exploring network and services deployment automation on CNF and QNF, let's say, principles and approach. As part of that, we are exploring, of course, agile development and cloud-assured operational principles such as cloud-native and immutable. And we are also following concepts driven by, of course, network and compute slicing, mobile edge computing, and cloud run deployment models. So our final goal for sure is of this, let's say, 5G assured port infrastructure is to support various use cases that will explore industrial IoT services, AI-assured video analytics, IoT-based telemetry monitoring, and drone-assisted surveillance. As such, we are targeting, let's say, 3 different groups of use cases. This is AI to automate container identification process and detection of structural damages on the containers. We will equip, or actually we have equipped already port trucks with IoT-based monitoring to assure telemetry automation and to capture, let's say, port vehicle status in real time. And we are, let's say, enhancing port operation with AI recognitions and drone, let's say, based wearable and also portable, let's say, UHD cameras, which will assure, let's say, video streaming over the 5G network to provide real-time common operational picture for the security, let's say, services. So we have developed, let's say, our Living Lab architecture and its capabilities by the concept of, let's say, modular building blocks. So we call it components that can be developed, deployed, and operated totally independently. Let's say this open concept allows us to extend Living Lab capabilities, which will be done, of course, during the project, and to host also various other use cases that are targeting, let's say, different port operational domains, such as could be cloud private security, could be logistics, or other, let's say, supportive services, such as remote crane control, where, let's say, strict reliability and low latency requirements, as you know, are really essential. So on this slide is presented our, let's say, Living Lab architecture, shown as a, let's say, full network services and also application stack. On the lower and middle layer, we support 5G network and IaaS capabilities, which are provided in 2 flavors, built over the public and fully private infrastructures. So we are testing both currently available 5G operational mode, that's this standalone and non-standalone operational mode. In the upper layer, we support services infrastructure and application enablers that are complementing, of course, our 5G ecosystem with industrial IoT gateways, 5G telematic devices, real-time video streaming, as mentioned already earlier, based on drones and wearable cameras. And on top of that, we conclude with AI-assured video analytics. So as being said, deployed Living Lab technologies are exploited by 3 use cases that are deployed and actually will be verified in operational port environment under the real conditions. So these use cases are the following. Use case 1, where we address network and services deployment automation based on MANO. Use case 5, where we are targeting logistic process automation for the ports. And in use case 6, where we are actually targeting 5G assured mission critical communications in the port. So to implement such ambitious goal in, let's say, I would say the port is really demanding environment, we got on board, of course, several partners, project partners, that are able to support cutting edge innovations in these 5G domains. These are, as already mentioned, Luka Koper, which is a port operator. So Telekom Slovenia, a leading mobile network operator providing port-centric network services over the public infrastructure. Vicomtech, which is a research center developing AI-based video analytics to automate logistics and security process in the port. Continental, industrial partner providing telematics IT platform, and of course, complementary analytics. And finally, Internet Institute, this is us, which we are a young SME delivering cutting edge, let's say, private 5G system and services, which will be extended with industrial IoT platform operating in fully 5G standalone mode. So in the following slides, we have prepared for you direct insights from the development of 5G and complementary technologies in this let's say, in our port environment. So Telekom Slovenian team has extended their commercial 5G networks to operate, to support also local breakout of port generating traffic. This means that in the port area, they have deployed mobile edge computing with dedicated SGV and PGV capabilities, of course, extended for non-standalone support, that enables routing of traffic generated by cameras and other sensors directly to local port YAS for additional processing. Of course, you can imagine what are the reasons. It is security primarily and also performance related. So on this slide is information from us, from SME Internet Institute. We have prepared our private 5G system that is operating in 5G standalone mode with 20-watt remote ready unit. So the solution is following cloud native and disaggregated run principles. As such, it operates on portable YAS and on top of Kubernetes cluster. So baseband unit and 5G core network components are prepared as containerized network functions with supported network services using Kubernetes deployment principles, which means we support Kubernetes manifest and Helm charts. Virtual network function descriptors, network service descriptors were prepared to allow the configuration of selected 5G core and run parameters such as mobile country code, mobile network code, bandwidth, TDD, operational profile, and so on. So deployment and network components scaling is fully automated in our case, and of course we support, let's say, or we target OSM 10 in this case. This is again something which is coming from us, from SME. We have developed this dedicated 5G IoT system to assure, let's say, 5G connectivity to non-5G devices such as HD cameras and other industrial sensors in the ports. So it is a distributed IoT system with non-standalone and standalone, of course, support. We need it because we have 2 types of deployments. And of course, it also supports NFV-ready system capabilities. So it is, let's say, distributed architecture and compromises a centralized cloud-based management, supporting remote, over-the-air deployments and configurations, etc., etc. So, but what I wanted to emphasize here is that the solution is again built as an open system architecture with cloud-native principles and API support. So basically everything what we are let's say deploying on top of this actually are containers, so API, user interface, and so on are actually prepared as a container functions, which are running in Linux OS. From the Continental partner, they have prepared 5G IoT devices that assure this automated collection of telemetry data, both via the vehicle CAN bus, let's say. So we are collecting full consumption, location of the trucks, etc., in the port. And of course, everything is stored in locally, and it is transferred to this analytics system, which is deployed, let's say, in Port Yas. So in the following slides, we have prepared, let's say, for you insights from our on-field pre-test that we did it already in the Copper Living Lab. As being said, let's say this is insight from use case 1, where we are focusing on network and services deployment automation. So it is not visible here, but we are using open source Mano orchestrator integrated with Kubernetes mechanisms that enables this on-demand provisioning on private 5G network and IoT services. It enables onboarding, deployment, and provisioning, let's say, automation, and so on. So what I would probably emphasize is only this, let's say, in current, let's say, results, or with current results or deployments which we are having, are really, really promising, I would say. We are able to deploy or redeploy, let's say, these basic network components, 5G network components, in 5 to 7 seconds, which means the whole core we can reconfigure, let's say, in 7 seconds if needed. So, and of course, on another slide here, you can see a snapshot of our drive testing results showcasing 5G non-standalone coverage. This is on the left side. And on the right, deployed analytics of continuous network and services monitoring, let's say, which we have deployed to support, let's say, and to monitor the 5G capabilities in our living lab. So as part of use case 5, as mentioned, we are testing, and of course, we're focusing on port operation, digitalization, and automation. And such, let's say, we have, let's say, automated container identification process and detection of structural damages using this real-time AI short video analytics processing, which is provided by Vicomtech. So video streams from deployed cameras are, let's say, on the STA screens are providing these real-time streams over the 5G networks, over the 5G network to, let's say, Port Yas, where additional AI processing is deployed. In addition to that, ports terminal tracks, as you can see it on the left side, used by the container terminal, we have equipped with IoT-based monitoring to assure remote telemetry and to gather vehicle status in real time. You know, this is the basic idea. So in use case 6, we explore everything that is related to 5G mission critical communications for the port. So we are targeting to enhance, let's say, port security operation with drone-based wearable and portable cameras, which will assure, let's say, again, video streams over the 5G network to provide real-time common operational picture in the security center. So to assure efficient video analytics in the context of, let's say, port security procedures, AI assured analytics is again, let's say, deployed to detect relevant security events, and this is again provided by Vicomtech. So, and we finally came to my final slide. So I have decided to conclude my presentation today with challenges that port will face when they will go for a production grade 5G development, or not just development, but actually the deployment. As with all new, let's say, promising technologies that you are introducing in that kind of, let's say, complex environment, you need to do your own due diligence, I would say. So in our case, these are, let's say, the 5G technologies related questions for which we, let's say, want to have a clear answer at the end of the projects, how we should, let's say, tackle them. So let this be also, let's say, an input for your checklist. Unfortunately, I guess we don't have time to go through the list, but I will be for sure happy to answer any questions if they will arise at the end. So finally, I would like to express my gratitude to be with you today and that I was able to share these key insights, let's say, from our living lab, Copper Living Lab. Of course, you can reach me if you will have additional questions, or I will be really happy to answer it also today. So thank you very much.
Okay, thank you very much, Janez. So with that, we conclude the presentations from 5G Login-Off, and I would say we keep questions until the end. So now we continue with affordable 5G. where first we hear something about the technical progress and the achievements from Panagiotis again. So I guess I have to make you presenter. So did that work?
I would say that you would make, probably it would be better to make Sotirios Pantheas the presenter.
Yes, thank
Oh,
you.
Because
Hello,
he's,
everyone.
I try
he's
to
going
do that.
to be, yeah.
Yes, but yes, Professor Trakadas already, I think, already
You're
highlighted the
already
technical.
your presenter, yeah? Okay. So
Yeah, so you can probably see my screen right now.
yes, we can see your screen. Can you go to presentation mode?
I'm not in presentation mode.
That's not what we see. No, the
Is it
usual
okay?
problem. You probably have more than one monitor connected to your PC, right?
No, I don't actually, but okay.
Okay.
Press Sotiri. The
Somebody
one
needs
that
to speak how to do it.
Okay, let me check. Is it okay right now?
Now it's okay, yeah. Go ahead.
Now it's okay.
Yes.
Okay, perfect. So yeah, Professor Trakadas already highlighted and summarized the technological evolutions of affordable 5G. So I understand that we're well below time schedule, so I will try to be very brief. And hello everyone, I am Sotiris Pantheas from the National Kapodistria University of Athens. I will be presenting our work entitled Run Optimization through Control Loop Automation that has been developed in the framework of affordable 5G. So, first of all, what are the objectives of our work? The objectives are to demonstrate the support of control loops in ORAN, Open Radio Access Network, by adopting open software solutions and embracing the concept of zero-touch automation. So on the one hand, open software solutions that are presented here are compatible with the ORAN specifications as they are provided by the Artificial Intelligence and Machine Learning official guidelines. And on the other hand, this work targets to design, implement, and test an accurate deep reinforcement learning algorithm, while also developing an automated model serving module using the TensorFlow serving platform. So let me summarize the key features of this work. So first of all, the configuration of RAN components through the interlinking between the near real-time intelligent controller called the DRAX and the RAN collected measurement is highlighted in this work. Moreover, we also present the development of a RAN parameter generator that provides simulated measurements of 5G compliant urban cells following 3GPP guidelines. And in addition, we also develop and implement and showcase the DRAX and associated inner modules, such as XApps, the data bus, listeners, publishers, and external containers. And we highlight the optimization of the RAN experienced throughput through power control based on deep reinforcement learning. And finally, we also show the integration of model serving functionality for automated real-time inference in control loop 2 of ORAN specifications. And the presented use case highlights clearly the practical implementation of a theoretically validated model running on a commercial RIA network product, which is namely the DRAX. And it should be noted that all the presented material here in this presentation have been deployed in the real network located in Castelloli infrastructures. So here you can get an overview of this work. So you can see that 7 steps can summarize this work, consisting of synergetic actions between Acceleran, Atos, and University of Athens. So the first 3 steps here cover all the required actions to design and deploy the initially untrained model and configure the RAN network generator. And by selecting a subset of training data in step 4, the ML model trainer is able to construct and upload the trained model to the catalog of the ML designer, as shown here in step 5. And all these actions, all these steps used Python, TensorFlow, and Keras libraries. And finally, as you can see in steps 6 and 7, the model container is deployed as an XApp in a DRAX instance at Castelloli after being packaged. And it should be mentioned that all the DRAX functionalities and inner modules have been developed by Acceleran, whereas the first 6 steps have been jointly achieved by Atos and University of Athens. So let me again briefly present the internal structure of an XApp and the architecture of this work. So the internal structure of the XApp, you can see it here in the left-hand side of the slide. And the orange boxes are pre-built packaged functions of DRAX that ensure information exchange between the XApp core and the near real-time RIC data bus, and also allow the dynamic configuration of an XApp. So the blue box here in the center is the core of intelligence in an XApp, and where the model inference code can be placed. And you can see that it can communicate with the DRAX data bus through a Kafka listener in order to read measurements and data, and also can publish values and data through the Kafka producer or the action taker, depending on the internal logic and functionality of the intelligent code. And in the right-hand side of the slide, you can see the specific architecture of this work that includes 2 apps. The first app, the XApp 1, is used to provide RAN measurements to the near real-time RIC data bus, and XApp 2 is for exploiting this data for model inference purposes. So a modification here, as you can see, is the addition of a TFS module that will be responsible for real-time model serving provision. Now, I will briefly mention a few things about the XApp 1. So in this work, we develop a general purpose flexible 5G simulator in the form of XApp that is Python based. So this simulator supports flexible topologies, power budget, user characteristics, and 5G numerologies that can be configured through a configuration file. The simulator also respects the maximum and the minimum power budget limitations of the radio units. The key features of the POS simulator is the calculation of the interferences, the channel associations, and the bit rate, the user experience throughput, based on 3GPP and 5G specifications of urban macro and micro cells, while the association of the user is based on the maximum throughput criterion. This simulator also supports user mobility and handover calculations, and also supports a varying number of users, since users may enter or exit the network area according to their trajectories. Finally, you can see here that as this simulator outputs a UE measurement report that actually contains 7 physical layer metrics, namely the RSSI, the RSRP, RSRQ, the CQI, and the ID of the associated radio unit, and the ID of the associated resource block, and the UE experience throughput. So regarding XApp 2, that's the DRL model, so we developed a throughput optimization algorithm through power regulation, while also simultaneously mitigating the code channels interference. So in DRL terminology, we have a centralized agent, which is located at the near real-time RIC, the DRAX, which interacts with the telecom environment. And the agent aims to maximize the total network throughput experienced by the users by observing the state space, which is the UE measurement report, and by performing beneficial or not actions, which is the adjusting the power levels of the radio units. So the agent is trained following a trial and error approach and gradually converges in power control policies that are beneficial for the wireless environment and ensure increased network utility. So here in this slide, you can see the practical implementation and interaction of the POS simulator and the DRL agent that were deployed in the form of XApps in the near real-time rig. So XApp 1 generates the 5G compliant measurement reports in a configured network topology and writes its network measurements in the near real-time rig database, which then can be used as a state vector to the DRL, the neural network, in order to infer the model and provide a corrective action, which is then published again back to the near real-time database. And finally, these corrective power levels can be applied to the environment and to a new state of the environment. And this process is continuously repeated to visualize the time course of the model inference performance. And it also should be mentioned that diverse objective-specific ML models can be deployed, Dockerized, and stored in a dedicated ML catalog for potential future inference. For example, these models may concern the energy efficiency of the power allocation or even spectrum utilization optimization. And seeing an example of this workflow, we have a network snapshot in a particular time slot, and we generate an instantaneous measurement report, which is then acknowledged to the DRAX database. And then this UE measurement report is used as input to the DRL model, and the DRL agent makes the predictions for beneficial power levels, which are then published back to the DRAX database. And finally, the suggestive power vector is applied back to the run generator, and this process is periodically repeated through time. Okay, I will briefly mention a few things about the functionalities of XApp 1 and XApp 2. So here you can see three indicative configuration scenarios of the POS of the Python simulator with 3, 4, and 5 cell topologies with different numerologies. And here you can also see the best condition user and the worst condition user in terms of experience throughput. And of course, the worst condition user is typically located in cross-border areas where the interference are high. We also, for these scenarios and for these simulations, we used heterogeneous demand points in terms of user mobility. So we assume some users to be static, we assume pedestrian, and some vehicles. And it should be noted that the average UE data rate is positively correlated with numerology, while the UE capacity decreases with a 5G numerology. And regarding the training and evaluation of the DRL agent, the training is performed offline using simulated measurements by the POS simulator. So in each training scenario, the initial power levels are set to the average power level. And here you can see the training process of XApp 2. We have plotted the reward function, which is the throughput increase in megabps for different values of hyperparameter gamma, which is the discount factor, and it's a hyperparameter of the DRL learning process. And we also use an linear epsilon decaying policy in order to transit from exploration to pure exploitation phase of the DRL training process. Okay, and finally here you can see the overall assessment, well, the integration of XAP1 and XAP2 in Castelloli. So having our DRL agent pre-trained on simulated network measurements inside a 3-cell area, we demonstrate the inference phase of the considered scenario. So as shown in the right panel, a 5G network topology consisting of 3 macrocells is considered here, following the specifications of a UMA cell of 3GPP specifications. So each radio unit has 12 available resource blocks to transmit data using the OFDM modulation scheme. So inside the network area, we have a set of mobile users with each individual user requesting a specific service, which is expressed in megabits per second. So at each time instance, each user follows a random walk model. So because we said we also support mobility. In addition, the network simulator here is aware of possible handovers, since a user may be served from different radio units depending on which is the best server for a given time point. As I already mentioned, the key functionality of the simulator includes the interference calculations for each user by not only considering the channel losses, but also the accumulated interference caused by the non-servers. Okay, so here you can see that the association scheme is implemented according to the maximum throughput criterion, meaning that each user equipment occupies a channel from which it receives the best throughput. So this information you can see is demonstrated here with different color coding, with red, green, and blue users being covered by the same color transmitters. Also, the boxes on top of its user represent the user-specific throughput value at a given time point. And in the upper left panel, we can see the time course of the total network throughput. We can observe that the DRL model can enhance the experience data rates of the network, being systematically higher than the non-DRL assisted case, which is the average power allocation scheme. So in extreme cases, like for example in time instance 3, where all users are located in overlap areas, DRL model can show degraded performance equal with that of the non-DRL solution. And right below here, we can observe the heat map of the time varying changes in the power levels of radio units and resource blocks. Please note that the algorithm only regulates the power factor to guarantee improved network-wide throughput. In any case, the benefits gained by using the deep reinforcement learning agents for optimizing the network utility are evident. So, in order to conclude and summarize the key takeaways, sorry about that. And so, what are the main outcomes of this work? So, first, we developed and showed a 5G simulator that is based on 3GPP specifications and can be used in general purpose network optimization scenarios. Moreover, we demonstrate how the O-RAN optimization and the automated model serving can be coupled to reach zero-touch automation and optimization. And this work, of course, showed the collaboration between industry and academia. So we had the Acceleran and Natos and University of Athens that were working together for this work. And finally, it should be mentioned that we had a knowledge transfer from theoretically published research paper that were finally integrated in a commercial software. So as future extensions in the second year of the affordable 5G, we intend to replace the XAP simulators with real A and B GNB measurements, and we also intend to address accuracy improvements in the DRL model, including also energy efficiency aspects. And finally, we intend to extend the open source toolset, especially for the training phase automation, which was now performed offline. I would like to thank you for your attention, and that's all from my part.
Hey, thank you very much, Sotirios. Very interesting. So
Okay.
I see that the plan is to go from simulation to real life in the next steps. That's quite good. So I guess that concludes the presentation from Affordable 5G.
Yes, exactly.
So then we can move to FUDGE-5G, where we first hear about the use cases for 5G private networks. And is that still correct that Kashif is going to present that?
I think he joined and he's online. So Kashif.
Yes, David.
Yes, so it's your turn to present.
Come again, David. What did you say?
No, that it's your turn to present.
Okay. I thought it was an affordable 5G, another presentation from affordable 5G.
Yeah, but
okay, so we have to make you presenter.
Thank you.
Right. Oh, so you're a presenter now, Kashif. Please go ahead.
Thank you. I should also share system audio and let me know. Turn off mute yourself. It says you are including media sound while sharing your screen. For the best audio quality, turn off your mic when you're okay. Good. And then we are here. You are able to see my screen?
Yes, so I see myself basically. Now we can see the presentation. Maybe if you can go to presentation mode.
How's it now?
It's perfect.
And do I need to switch on my video, or how is the? Do I also need to switch off my camera, or shall I do it without that?
Keep it on.
Okay.
But please go back to the presentation.
Okay, then I remove this, and then we are here. We are here. Okay, then you are here, right?
Perfect. Yeah. Let's
Good.
go ahead.
So hello everybody. I have 15 minutes, right? So it's 14:25. So I'll finish at 14:40. Okay. Great. So this is part of the FUDGE-5G project. I am Kashif from Telenor, technical manager of this project as well. Some numbers I would say with regard to FUDGE project. Fully disintegrated private networks for 5G verticals. So if I really break it down, it's basically two things. One is that all of the use cases are on private networks, which you will see in a meanwhile, and then the fully disintegrated part. I think that's also very important. I always say this thing when we had this, what I call NFV 1.0, where we essentially decouple the hardware from the software, but still the software which we got as a result of that was still quite monolithic, right? So the plan over here is in FUDGE 5G and overall the way the industry is moving to have more of a cloud native approach where this software is also disintegrated, so such that there is minimal coupling between the network functions and the underlying platform. Not only that, for example, there should also be no coupling whatsoever between the tools, for example, which are used for observability, etc., with the network functions. So that's the overall aim of this project when it was submitted, and that still stays the same. This second part, Sebastian has a presentation afterwards. He will go more into details of that one. What I will do now is I will give you an overview of all the 5 use cases which we have in FUDGE 5G project. It's a project with 12 partners and 10 countries. It will be ending in February 2023. With regard to the 5 use cases I already mentioned to you, those are public protection and disaster relief. Likewise, we have 4 others. The way we constructed the project was for each of the use case, we had a stakeholder. For example, for the PPDR, we have the Norwegian Defense Material Agency. Likewise, for concurrent media delivery, with the stakeholder is Norwegian broadcaster NRK. For those who don't know NRK, it's sort of I can call it the BBC of Norway. Then we have the virtual office, where it is with Oslo University Hospital, Industry 4.0 use case with ABB. And then I would call this last one as a bit of a fancy use case, interconnected private networks or non-public networks, as 3GPP calls it. This is basically capturing the use cases where there are different private networks and you need to interconnect them for some reason or the other. As an example, imagine the case that ABB, I mean tying this one to this one, imagine ABB has number of industry floors. Let's suppose one is in Norway, the other one is in Germany, etc. How, and each of that network is a private network. How do you interconnect them, right, in order to provide some unified services? So that's one of the case for interconnected NPN. The other could be, imagine number of football stadiums. Each football stadium is a private network, but then all of them are connected, and that also makes the case. And finally, the use case from which we got this idea was the EDU-ROM use case, where, as you know, EDU-ROM is the Europe-wide internet network for the universities, where different universities collaborate under one umbrella. So imagine each of those universities being a private network, and then we create a Europe-wide educational network, and that is also an interconnected private network. The rest of them, PPDR, I touched it briefly. Concurrent media delivery is essentially about providing, as it says, immersive experience for multicast, and also we are doing remote news gathering use cases. 5G virtual office, the name is virtual office, but then it is quite focused on the hospital, and there the aim is how we can connect the different devices and services and make sure they are all connected over 5G. And then one of the main motivation for doing 5G in the hospital is in order to make sure that the data does not leave the vicinity of the hospital. That is one of the motivation for private network. And the second motivation is for many of their use cases. For example, we did a use case on remote ultrasound with the hospital that requires that low latency as well, because it involves haptic feedback. Industry 4.0, the main focus over there is 5G LAN and TSN capability to be provided to the ABB industry floor. So this was a quick overview of all of them. I will now go into the detail of some of them, not all. So the first one is a PPDR use case. As I told you, this is more about building standalone 5G bubbles, number one. And in the second phase of the project, which we are working now, what we are doing is we will also do PNI and PN use cases, where it will be also how to integrate those private networks with the public networks. At any stage, if anybody has any question, feel free to stop me. I've just collected some slides, but feel free. I don't need to go through all of those slides. If you have any question, just stop me, ask me. Okay, so for the first use case, I have actually a small video which is from a demo which we did at the Riga Military Air Base, which is about a search and rescue operation using 5G standalone and using the network of FUDGE-5G. So you can watch that, and then I will explain you what happens in that one. I will just play it for a while and then pause it in order for somebody can shout that if he can hear the sound, because I don't know if it works right away. So
we can hear the sound. Yes.
Okay, super. Then I will let it run. It is a short 2-minute video. Autonomous private 5G network using 5G standalone. The radio, the 5G core, and the different applications. For example, video being distributed to multiple parties. That was all hosted inside the cell on wheel which you see in the background.
we have demonstrated practically here today is the ability to increase the level of situational awareness, and thus being able to, for instance, live stream video from an accident site like Gjerdrum and distribute the live feed to every emergency services personnel responding in real time.
So we want to get a defense slice or a slice inside the commercial networks. So the private networks is something that comes in addition to guarantee coverage and of course quality of service.
So this was I'll explain you what happened in this one. So this was another, demo which we did, and the main aim of this one was, our partner in this one, apart from Norwegian Defense, also we had Norwegian Air Ambulance, NLA, in this one. So the scenario is most, this slide is for the different landslides which have happened in Norway in those 2 dates, and in such a scenario either the network might be broken or the coverage might be patchy in that area. So this is where this network on wheel makes a lot of sense. And when I was talking to our stakeholder, which is Norwegian Air Ambulance, I asked them, in a typical search and rescue operation, what are the typical requirements from your side? So they explained me these 4 things. They need to have better situational awareness, what has happened. They need to have coordinated operations such that all the relevant authorities, the hospitals, the police, the rescue mission, the rescue guys, all those need to be on one page. So that's the coordinated operation. And of course, in this particular case, you do need to have guaranteed performance. And finally, all this needs to happen as fast as possible in a timely. So that's the timely response part. So our network on wheel which we have built, it is just a matter of putting a power on button, and then it gets up and ready in I would say not in more than 5 minutes. So that's how quick it is. So the scenario which you saw now was the following. We had a network on wheel, a military vehicle which you saw, and in that one we have in this particular demo we had the AWS Snowball Edge. That's a small ruggedized server, not really a small, I mean it's a very powerful one, and on that server we had the 5G core application, 5G core from Athonet, and then we had another application from OneSource for situational awareness. I will tell you what is the role of that one. And we had the radio. All this was on 5G standalone. And then the aim was, we had a dummy doll, as you saw in that particular video. It was on the roof, and the drone which was 5G powered, and the way we made it 5G powered was not that it had a 5G modem inside it. We taped a GoPro camera and a 5G modem, a battery powered 5G modem. We put it together, and that's how we made it 5G powered. And then it first found the doll in that particular video, and once it found it, then the first responders, you saw 2 people going on the roof. They were wearing the kits from OneSource, and they were also streaming the video from the incident place to this is the role of the situational awareness application. The video from the drone and from the first responders comes to this particular application from OneSource, and then it gets transmitted to the police control room which was being done, and also to Norwegian broadcaster NRK's primary control room. And the way it works, Norwegian Air Ambulance, NLA stands for Norsk Luftambulanse, or Norwegian Air Ambulance. They sent them a message, and once they open that message, then the video link opens, and they were able to see what was happening. We have the possibility, and also all this event was being broadcast by a 5G powered camera as well. At the moment, in this demo we only had the use of situational aware application, but in addition we have also onboarded the gunshot detection application and a TVS, a tactical voice system from Thales as well. So this is all inside the Snowball Edge. And in addition, there are some proprietary applications which the defense have. They don't need to sit in here. So we have the possibility to onboard any edge server. In this case, it was from the defense, and they used the similar setup actually in I think it was in February or March. There was a NATO exercise, and it was also used over there, where they had their applications running over here. And the aim over here, next aim which we are now working on, is At this time we only had the drone video transmitted over 5G. The next aim is to have also the drone control over 5G, and we are working with Intel also to have AI capabilities inside the network on wheel, such that the video is processed in the network on wheel, and then we can identify the victim much earlier. So this was the first use case on the PPDR one, and overall, FUDGE 5G project and the previous project 5G Winnie, which we have been part of, they have been mentioned in the NATO's report as well as one of the leading in terms of the 5G trial projects when it comes to military use cases. The second one is on the concurrent media delivery. That is again about having flexible remote production using 5G. I have a very small video here as well, and I'll then explain you the setup of this one.
My name is Birger Henriksen. I work in TV2 Norway with 5G. 5G gives us possibilities for remote productions. It gives us the possibilities to cover small events. But we need bandwidth in another way than telcos usually want them. We need a high upload. They usually need a high download. Some places, public network will be the solution. But many places we will need non-public network, standalone network, to make secure productions. If you are a host broadcaster, you don't want to rely on any other than yourself.
So in the current test that we're running more efficient workflows, running both a local production unit, but also a clouded production unit running simultaneously. That allows our users to access content and the tools that we're using instantaneously in the cloud. And as a backup, we're also able to access all our central production resources locally and maintain production even if the backhaul falls down.
Hi, I'm Eric Woll from NRK, project manager of the 5G project here, and we are currently doing an IP production. We're also hoping to extend this into wireless access in areas where we need coverage, and that is what FUDGE-5G can help us with, testing out 5G private networks. So we're hoping this to be production ready quite soon, and I think these trials is very promising and of course give us an indication of what is possible in the future.
FUDGE-5G is an EU-funded project which is only focusing on private networks. What is important to highlight for the private network which we have deployed over here is, number one, coverage on demand, but the second most important thing is we are providing super high uplink throughput, which is needed for this production which is happening today. I just realized I've exhausted my time. So one thing I just want to mention for this particular use case is, we tailored the private 5G for this, our 5G network for this one, because as you can imagine, this use case is uplink intensive. So what we did was we changed the frame structure. Typically it is 4:1 in a commercial, at least in Norway in the commercial networks, but we changed it to 7:3. So this is the ratio of downlink to uplink. Downlink to uplink like this, right? So by doing it 4:1, it's more about 20% roughly is the uplink, but if you go to 7:3, then you increase it to about 30%. So that's what we did, and then you see only with 40 megahertz bandwidth we were able to achieve about 115 megabits in the upload in the speed test. But also I want to make a disclaimer here. What we have noticed in this particular use case, the doing speed tests is really misleading in terms of what the actual application needs, because right now as we speak we are testing it with the applications from NRK as well, and there we see that in order to do a reliable transmission, you cannot go really around 115 because even around 30 megabits or so, we get such a high packet loss. So this is some optimization which is in the pipeline. With this, I will mostly end. There are other use cases as well which we have, but I will skip those in the interest of time. I will just say the final word, and that is the following: that private networks, this is also what I internally communicate in Telenor as well. It's not only providing, a 5G network, which is the communication technology. The main aim of the private 5G network is to offer a unified solution for the enterprise where we combine the 5G from us, we combine their IT technologies or solutions which they have, their data technologies forever machine learning, etc., and the operation technology. And all this should be done so that we are able to provide a unified solution for the enterprises in order to provide them guaranteed performance. And finally, based on our experience in Telenor and in this project and in 5G Winnie, what we have realized is that we need to start working with the verticals quite early on and have a sandbox environment. So I always see these EU projects as a sandbox environment where you can experiment with the verticals and then eventually those become commercial successes. So with this, I would stop. If you have any questions, please ask.
Okay, thank you very much, Kashif. I think we take the questions at the end. So that was quite interesting and nice videos. It was nice to see some snow while we're here in the middle of summer. Okay, so and then we have a second presentation on FUDGE-5G on the platform architecture by Sebastian Robic from Interdigital. So we should make Sebastian presenter. I think that's all the time Anna that's doing that actually, because I can't. So Sebastian, you should have the presenter right now. So we see your presentation. Now we see it in presentation mode. Perfect. So please go ahead.
Great, thank you, Peter. Right, so basically I will link to what Kashif presented and talk a bit about the platform underneath, how to enable such flexibility and things like deployment within a snap of a second, that we simply have something up and running. So yes, so basically I have two parts in the presentation. One is on the SPA, so what do we do in FUDGE around the SPA topic, and the other one is how do we actually demonstrate technology. And I give you a small example, which was essentially part of the demonstration I gave last week in Grenoble at the UCNC. So some reasons always right. So service-based architecture in FUDGE-5G. So service-based architecture, in a nutshell, is basically the ability to adopt cloud principles in the telco domain. The cloud world is probably 10, 15 years ahead, and when it comes to software design patterns, how to scale services up and down, also make them reliable, redundant, but redundant in the sense of, again, lifecycle management. So those cloud principles is really something that the telco world since release 15 has adopted. Mainly you see this in the 5G core, but also in the RAN. In the 5G core is essentially, since release 15, we have HTTP2 as the application layer protocol across the majority of the core network functions, and we have JSON encoded payloads to exchange information. Also with release 16, there's an optional component called service communication proxy. And this component essentially allows you to, as the term implies, to perform routing between instances of a 5G core instance. So the key why 3GPP adopted a service-based architecture is essentially multi-vendor deployments. Multi-vendor in the sense of you bring maybe one network function doing I don't know, a specialized user data management from vendor 1, and you have an AMF from vendor 2, and you come with the UPF from vendor 3. But all should actually be deployed in one single core, and they should simply work. Now, Kashif mentioned this already. I just basically is an extended list of the innovations we have in the project. So we have this evolution of service-based architecture, which I'm talking about. We have 5G LAN demonstrations. We have TSN integration, even 5G multicast on a conceptual level, knowing there's no broadcast capabilities or multicast capabilities on the new radio yet. The interconnected NPN. We have something around resource scheduling and service routing among those 5G core network functions, orchestration, and also with the focus on the 5G core, this end-to-end notion is something we also adopted in trying to bake into our unification aspect within the project. Now, talking about the proposition of FUDGE. So service-based architecture, again, as I mentioned, the adoption of cloud principles, but we add this unification aspect to that. So unification here is essentially that the platform that sits underneath the 5G core offers something in unified fashion to everybody on top. And basically, everybody on top has no chance but to use the functionality underneath. A bit like if you go to Google on the web, you have to use the internet. You have no other way to reach Google, a bit like in that fashion. So the platform that the functionality the platform offers is service routing. It offers location-aware, typo-centric, cloud-native service orchestration and telemetry. And the technology demonstration, as Kashif mentioned, is always conducted in a private network setting. Now, also for the platform, quite importantly, you see this later in one of the examples of doing technology demonstration. Location awareness is something in the telco world that is quite different to the cloud world. We all know that the edge allows us to bring down the latency, to stabilize jitter, to increase throughput by simply distributing the load across the system. But edge also means you basically have all of a sudden multiple locations which you have to take into account when you orchestrate, when your lifecycle manage. So that's why the location-aware typo-centric cloud-native orchestration is something that the platform really offers in a unification aspect. Now, basically, this is the like a high-level overview of what we're doing in FUDGE. So you see at the bottom an infrastructure layer, on top you see a service layer, and in the middle you see a platform layer. And those dotted lines in between, you should see them as programmable interfaces from the north to the south. So the line on top, the dotted line, is basically the service layer can programmatically change resources in the platform layer, and the platform layer can programmatically change resources in the infrastructure layer. In FUDGE-5G, we, I wouldn't say demand, but we really like to see Ethernet throughout. So basically in the RAN, but as well as in the core network area. So even if the core has to communicate between two entities, we would like to see Ethernet in the domain. We integrate nicely with SDN switching fabrics, in this case OpenFlow. And we would like to see a programmable infrastructure when it comes to orchestrating our platform components. So the platform we see in the middle is essentially well, a software, and software has to be orchestrated and managed somehow. And with NFV, essentially, we can automate the process already. Now, the platform itself, as I mentioned before, has certain functionality that is offered to the top there. The functionality here, you can see 4 boxes. Against the routing, and what we understand on the routing really is the ability to allow the routing between 2 instances in a location-aware fashion through the entire network where the 5G core is deployed. So if you, for example, bring something up and down, or if you have certain congestion in the service, or you know, redundancy you need, the routing should be able to support any change in execution points for HTTP communication on the fly. So if you change an instance saying traffic X should go somewhere else, the routing underneath should simply support this in a matter of milliseconds without any complexity when it comes to state in the network and so on. The orchestration, as I mentioned, location awareness is quite important in the target domain. So the FUDGE-5G platform comes with its own orchestration layer, and tightly connected to orchestration. In order to make decisions for lifecycle management of services on top, you need to have a unified telemetry, so that you have the ability to not only programmatically define how to actually perform lifecycle management of instances, but also being able to simply measure from ideally all layers information in order to make decisions. And then the last piece which we're adding in the platform layer is slicing capabilities. Now, explicitly, this is not saying network slicing, it says slicing. So you see, we do support if the interface towards the GNOB, for example, is available, access networks for network slicing. But we also see slicing as a principle that simply allows you to isolate between the isolate communication. And if you isolate, you also want to do some sort of QoS enforcement, which is essentially slicing. And we add this for any service that runs on top of the platform. So this is really beyond the network slicing approach, what we can currently see in 5G. And now on top, and that is the, let's say, the cute thing here, for the platform, everything on top is just a service. It sends packets from A to B, ideally HTTP, because then we can perform service routing as the platform. Whether the service implements a 5G core or vertical application, the platform itself is absolutely agnostic to that. Now, how does this manifest really then in demonstrating the technology? So you've seen those 5 use cases, and I'm not repeating necessarily each of them. I just want to basically demonstrate that we are demonstrating the platform capabilities with verticals using our stakeholders, and they are our key drivers to bring the use case for the private network setting. When it comes to the entire workflow, we do have an internal test bed in FUDGE-5G to test the integration and all use cases actually utilizing that, and we have this a workflow internally established to go from the development from components by each partner into an integration testbed, from where we go then into Telenor and actually try or experiment within the private network setting, and ultimately running a trial. Obviously, this is all interlinked in a feedback loop. Whenever something breaks, we go back basically instead. Now, when it comes to what we actually do a bit different, so this is now the current 5G system architecture. Most importantly, the service communication proxy is an optional component, so it's not mandatory to use it. But obviously also with that, it comes the challenge of, well, if you do not use that, who is doing the routing? Well, it has to be either manually or statically configured, or there's some logic in the NF, for example. Also, when it comes to service-based architecture and the ability of network functions to utilize cloud principles, the AMF, for example, sits in both worlds. On one hand side, you see the NAMF interface, which is a service-based interface. And on the other side, you see the AMF still living in this legacy world of the N2 interface. It is peer-to-peer connection with the GNOB, in this case, uses SCTP. And the SMF has the same challenge there. The SMF lives in the service-based world as well as in the peer-to-peer world. And the UPF, which is a 5G core network function, is not service-based at all. Now, what do we do different now in FUDGE? Well, the thing is really, we don't want to, and we can't change how 5G core really operates, because we have 3 different 5G core vendors, and we can't necessarily ask them to re-implement the core to demonstrate or to really change behavior and methods within the core. So what we're doing instead, we simply go a bit beyond the current system architecture without changing necessarily how our core works. And we really want to, and we have demonstrated this at the USANC last week already, we can do this without the 5G core vendors having to change anything. So what you see here is not something radically different, but if you look at it more precisely, you see quite a number of important changes. So you see here the SCP out of a sudden is not a box anymore, which you can address. And this is one of the biggest changes. So the SCP available to FUDGE is mentioned in the standard in 23.501 in the annex of one of the 3 deployment options. But this SCP is not addressable. Like on the internet, you don't type in internet/Google, you type in Google, and the internet simply routes your traffic. The same way our SCP is not addressable as a routing component. You address the service you want to go to. And on top of that, we also add the N2 and N4 communication over our SCP without, again, the access network or the UPF being aware that they're actually using a service routing underneath. We do not change the protocols that the N2 and N4 are using, but we have the ability to simply say, well, we already can route traffic over SCP, and we might have some cute little magic to maybe here and there help a bit when it comes to redundancy, or if there's issue when it comes to reaching the endpoint they want to go to. When it comes to technology demonstration, I mean, that is an example of our testbed, but also demonstrates the location awareness. You see here, I see dotted lines. They are basically OpenStack compute hosts. They're all in London. That's the integration test we are using. And we see at the bottom bare metal deployments of the platform. And just to perhaps also say this at this point, each of the colored boxes are platform components, and they basically form, you see in the bottom right, the key. We have two orchestrators, a service communication proxy, and a telemetry component. You see now at the bottom, this is perceived as the, let's say like a local far edge. This is like on premise. You have a G node B, you have the UE, and some bare metal deployments. Most importantly, the components called something -sh. They are so-called service hosts, and they can onboard any enterprise service. So we have the ability now to orchestrate a core or vertical application into 5 different locations. And the orchestrator is basically supporting this sort of orchestration template. So as an example, what we can do, we can keep, for example, UDM and UPF local on-premise. We deploy somewhere in the data center, AESF, NRF, and then somewhere more closer to the edge, other network functions that are required for the 5G core. And in this case, again, demonstrated at EUNC last week, the vertical application was deployed again on premise, and we kept traffic locally between the UE and the vertical application. And this sort of flexibility is all driven by an SPA platform that allows you to perform service routing, to perform orchestration, and to have telemetry in case you want to change any of the instances or the number of instances of, let's say, SMF. You have a platform that simply can breathe and allows you to breathe. And this brings me to the end of the presentation. Thank you.
Okay, thank you very much. So that was quite interesting also. So now we've gone through all the presentations. So now we have 15 minutes left, a bit less than we had planned. But first, are there any questions from the audience? That's your chance to know more about the 3 projects. Well, don't be shy. Well, doesn't seem anybody wants to ask questions. So in our agenda, we have said that we do a little panel discussion with the members being Professor Tracadas and Professor Gomez Barquero, and from 5G Loginov, Pavlos Basaras. So as there are no questions from the audience, maybe you have to answer the questions that I have somehow came up with. So we heard now interesting things. 5G Loginov is doing things in ports and around ports. Affordable 5G works on X apps and simulations, but with a view of replacing that with real ENBs and GNBs in the future. FUDGE-5G works on private networks, helping maybe in the use cases to save lives in case of catastrophes, or have high uplinks in case of sports events, as I saw in Norway. And now just a question I had. Well, this is now all on 5G networks, and everybody says, oh, 5G, that is the big thing now, and it's much better than anything else. But my question would be now, for your project, is there anything that was really making the difference? Is there the one thing that you could have not done without 5G in your projects that you would particularly point out? And then as a second question to this, second part to this question, are there things that you still cannot do with 5G and that you would like to see in 6G? So I hope my question is clear. So maybe I just start with Professor Tracadas. You have any idea on that?
Yeah, with respect to things that we wouldn't have done without the 5G network, I would say that there were some cases where the latency requirements were quite low. And that means that in some occasions, we were going beyond the 4G requirements. But on the other hand, I would not say that all the use cases and everything that we have tested and validated and demonstrated during affordable 5G, you know, they are going beyond 5G, leading to something that it is that fast or that demanding that cannot be done by 5G. I say that one thing that we wanted to experiment on, and that it is already under the the radar of the 3GPP documents, are some aspects related to the radio access network, in particular these multiple sessions, dealing of course with multiple slicing options. But this is going to be investigated in the next round of 3GPP documents. And this is something that we would say that it is well beyond 5G.
Mm-hmm. Okay, I remember that there were things that were not defined yet in standardization.
Yeah, correct. But yeah, for sure, we have exceeded the capabilities of the 4G in some of our use cases, and yeah, towards this direction, all the 5G concepts that we have undertaken in affordable 5G was quite interesting. Yeah, that would be my first answer.
Okay. So.
Yes, and I will say, well, because I've been last week at the UCNC and this week in another conference, like, well, these projects are actually supposed to be like evaluating advanced features of 5G. And it's true that maybe the marketing or the hype of 5G made a lot of well, noise, and there is actually a lot of work to be done, especially when coming to, when thinking on verticals. But definitely, as Panayotis has said, the performance of 4G has been improved. There are several clear benefits, and let's say 5G helps. It's definitely better than 4G, but maybe one problem is that the marketing of 5G said like 5G will solve everything, and that's maybe not true. Well, maybe that's actually not true. And so for example, for content production, to me that's a clear 5G use case. The industry, and it's just you just have to take a look to the industries that are really considering deploying 5G or making use of it, you know. And for example, this PPDR, well, the possibility of having this network on wheel. Of course, you could do it with 4G, but with 5G performance is better. The core, it's more cloud native, even if it's not 100%, let's say. So there are clear benefits, but when in my point of view, when considering the implementation of 5G like a commercial success, there's still a lot of work to be done.
Okay.
And the technology, for one reason or the other, you know, like pandemic, semiconductors crisis, and war zone, technology is not yet mature in the sense that 5G actually is release 16 is not commercially available everywhere. Like there are no devices. So and 5G release 16 is actually the one that meets the IMT 2020 requirements. So it's not that we are saying, no, it's just some additional features. So it's important features. So, well, I also think that, well, now we are being pushed to start working on 6G research, where there is a lot of course, a lot of work to be done from scratch, but personally, I believe there is a lot of work to do on 5G yet.
Okay, thank you very much. Yeah, that's a bit what I see in the projects that I'm working on. But we must not forget the 5G login-off. So, Pavlos, do you have to add anything?
Yes, well, we had a very interesting discussion, and we all need to remember also that even the promises that of 4G made initially, they did not get delivered, from year one of year two. And as we all know, 5G is going to show its true face in the years to come. And speaking from the European maybe ports perspective, we have seen through our work and through our collaboration with the other ports that really the non-standalone version of 5G is not going to really do the trick for building, let's say, maybe, well, but no, I won't say the ports of the future, but let's say the industry of the future in general. We have seen that we will be definitely needing slicing to, let's say, address use cases that are related to autonomous vehicles, platoons, precise positioning. And when we talk about teleoperation scenarios of trucks, for example, of vessels, of cranes, all these promising services that will expedite the port operations, building greener ports or safer ports for our employees, we really need to invest in the full agile capabilities of standalone core of release 16 and beyond. Now, if we need to take, let's say, the first steps of 6G network or 5G plus, if we want to name it like that, I guess I would see a wider application of edge computing and the need to support new classes of requirements with respect to compute and capacity, to support intensive applications, well, more intensive applications, and maybe the buzzwords that we continuously are hearing and we will keep hearing with respect to augmented reality, virtual reality, mixed reality, digital twins, and all these, trends that are really going to show their true faces and capabilities and in, let's say, a more strong network community. And I would also maybe finalize with that the native support of AI and machine learning applications being as, let's say, an inherent characteristics of our network environment, we definitely bring new use cases and new challenges for us to move forward with our work, with our progress, industry, and all the verticals that we're trying to address through our communication networks in a way.
Okay, thank you very much. Yeah, so you need standalone networks to do really your job in the ports. Yeah, and what I understood from FUDGE-5G, there's also the focus on private networks. And well, I ask again the whole audience, are there any questions now, maybe from the short discussion we had right now? Still not. Well, we are nearly finished with our time, so we are in time. So just one question for my own curiosity. So, well, we learned that some things in standardization are still missing. I have to say yes. I'm working also for ETSI in writing test specifications, and some of the release 16 specification I've been working on, they don't seem to be really fully stable yet. But another question, in implementing the project, like really the practical phase, what were the challenges? I'm asking that because in other projects we have the problem that hardware is not available, and then frequency are allocated to the project, and then the allocation is withdrawn, and things like this. Did you make similar experiences in your project? Maybe we start again with affordable 5G.
Yeah, to be honest, we are facing many challenges in affordable 5G. This is exactly what David said before. It is not, well, it is a fact that 5G has been rolled out, but it is not the fact that everything that 5G was promising, it is there. And it is playing seamlessly without any issue, and everything is perfectly, smoothly running. So with respect to the challenges, yeah, we faced some of those, and we are still facing. One that it was hard to tackle with was based on our decision to follow the Open Run approach and all the specifications that were there in the ORAN documents. I have to tell you that integrating components like the RU, the DU, the CU, and the non and real-time radio controllers as part of the ORAN and integrate them together, it is a tedious and very risky, I would say, task that it is not easy to fulfill for two reasons. First of all, because some of the specifications are not complete or are not there yet. And the second one, because as always, the implementation of the specifications, even if they are fully described, well, from developer to developer and from implementation, there are some differences. So yeah, all these, integrating all these Lego blocks of the Open Run architecture was a tedious task and a real challenge. The second challenge is with respect to the frequency bands and the support from mainly from the UEs. This is something that we are facing in affordable 5G.
Okay.
So
that is a similar thing we're facing in another project where a frequency had been assigned, and then after a while it was withdrawn, so it couldn't be used. And then you need new hardware where you just had to install the old one in it. Yeah, I know, I see the problem.
Exactly as you said, Peter. Yeah, exactly.
So but maybe for FUDGE-5G, you want to add something?
Well, just maybe quickly, just to say we haven't had issues with Spectrum, yes, but because having a Telenor, very reliable partner on that. But we, like especially, we are working on TSN, low latency, and so on, and we are, 2 years ago, we thought that by now there will be release 16 devices available, and they are not. And there are still few prototypes. They are supposed to be arriving, but it has been delayed, and that's I think all projects are experiencing these issues with the delays of technology.
Yeah. I have the same in some projects I'm involved in. Thank you. And then last but not least, I want to also give Pavlos the word.
Yes, I mean, pretty much the same challenges are present in, let's say, our project as well. One thing that I could add is that, you have to understand that we're doing deployments and use cases in active living labs in ports, which, deal with daily port operations, have their own unique characteristics in terms of infrastructure, network conditions, etc., etc. And we really need to roll out our development, our trial activities, in such a way to follow their privacy considerations, their security, and any internal procedure that they need to have. And of course, hardware availability was also a problem for us, and it still is actually. And as you understand that Loginov is, let's say, a project that deals with import and outside the port of premises. So basically, I guess Hamburg also had to deal with also a lot of other regulations with streets, with road traffic, coordinations, and all that kind of stuff. These are all the challenges that we kindly faced in all the rollout phases of our projects.
Okay, thank you very much.
Peter, maybe I can just complement one thing Pavlos just mentioned from the city of Hamburg, because as this 5G, 6G aspect and beyond 5G was discussed, and I'm in the 6G task force discussing also a lot of these activities happening there. I think what is very promising from 5G Loginov perspective is that going towards digital twins, where the city is a digital twin, connecting the different intersections, connections to the port, intermodal, everybody doing these projects in the traffic management side of Hamburg says there's a clear need for 5G and even more, because when you have 1 million vehicles of a city and 8,000 trucks going to the port, and you simulate what type of traffic management signaling is the best, everything has to happen very fast and similar to weather in an intelligent way, exactly as the 6G networks are discussed. So I think we are on the right track with these activities in these 3 projects. There is a need for improvement, not only for consumers, but also for a lot of applications we started in these 3 projects.
Okay, good. And before we close the call, I want to thank everybody for participating, especially the presenters, but the whole audience for their attention. And Panagiotis had the idea that we maybe could switch all our cameras on, or the ones that are properly dressed at least, and make a snapshot of the meeting. I think there's a restriction, so please, everybody that is still awake, switch on your cameras. Oh, there are only a few people coming in, so, well, anyway, I make a print screen and then we'll see. Okay, then thank you very much. And I think it was an interesting workshop with 3 projects that all work on 5G, but cover really quite different aspects of it. And I thank you again, all presenters, for the interesting presentations. I thank Anna for organizing the whole event, and all the participants. I hope it was interesting to you. And with that, the only thing remains is to wish you a nice rest of the day and talk again soon, hopefully. So
thank you.
Goodbye.
Bye.
Thank you. Bye-bye.
Bye.
Bye-bye.
Thank you.
Bye-bye.
Bye.